by GE Aviation, Ashland, CBTS, Encore Technologies, Morphic. Join the conversation. Tweet us at BSides Cincy. The stream will begin shortly. BSides Cincinnati 2016 is sponsored by GE Aviation, Ashland, CBTS, Encore Technologies, Morphic. Join the conversation. Tweet us at BSides Cincy. The stream will begin shortly. BSides Cincinnati 2016 is sponsored by GE Aviation, Ashland, CBTS, Encore Technologies, Morphic. Join the conversation. Tweet us at BSides Cincy. The stream will begin shortly. BSides Cincinnati 2016 is sponsored by GE Aviation, Ashland, CBTS, Encore Technologies, Morphic. Join the conversation. Tweet us at BSides Cincy. The stream will begin shortly. BSides Cincinnati 2016 is sponsored by GE Aviation, Ashland, CBTS, Encore Technologies, Morphic. Join the conversation. Tweet us at BSides Cincy. The stream will begin shortly. BSides Cincinnati 2016 is sponsored by GE Aviation, Ashland, CBTS, Encore Technologies, Morphic. Join the conversation. Tweet us at BSides Cincy. The stream will begin shortly. BSides Cincinnati 2016 is sponsored by GE Aviation, Ashland, CBTS, Encore Technologies, Morphic. Join the conversation. Tweet us at BSides Cincy. The stream will begin shortly. BSides Cincinnati 2016 is sponsored by GE Aviation, Ashland, CBTS, Encore Technologies, Morphic. Join the conversation. Tweet us at BSides Cincy. The stream will begin shortly. BSides Cincinnati 2016 is sponsored by GE Aviation, Ashland, CBTS, Encore Technologies, Morphic. Join the conversation. Tweet us at BSidesCincy. The stream will begin shortly. BSides Cincinnati 2016 is sponsored by GE Aviation, Ashland, CBTS.
All right, everyone. So our next presenter is Warren Kopp. I pretty much have to yell in this mic, actually. Sorry. He joins us all the way from Cleveland, so pretty good distance. But yeah, thanks for showing up, and go ahead.
All right. Good morning. Thank you all for showing up and staying through the keynote to me. That's very exciting. It's a large group. It's wonderful to see so many people here. Before I even tell you who I am, again, big thanks to the organizers. I have a little bit of insight of what it takes to put this kind of a thing together, and this is a fantastic event. They've all worked very hard for us to get here for almost nothing, so big hand of applause for them. And so who am I? I'm an application security specialist. We don't abbreviate that one, by the way. I work for a fairly large software company. Our product is over 20 years old, and in the last 3 is when we've really started to take application security seriously. So there's a lot of implications with that. There's a lot of security debt. There's a lot of learning as we go. There's a lot of looking at the bad habits we've built up over the years and what we've done with that. So with that security debt is where my talk comes in about threat modeling. I'm going to go into the more specifics about that, but most of what I've been doing is teaching. I've been teaching security to people who don't know, haven't done it, or don't care about security and why it matters to their jobs. It's not just the developers, it's not just the QA testers, it's the sales, the installation, the support. Everyone is involved in the security of our product, and they all have to learn from different levels. So before I break into threat modeling and why I think that matters to everybody, infrastructure, software, whatever, I want to go over a basic concept. Has anybody read this book or have an idea where I'm going with this? This is rubber duck debugging. And the way the story goes, paraphrased and shortened, is that there's 2 programmers working at a company, a young one and a wise old programmer. And the young one comes up to the old programmer and he says, I've got this problem, I'm stuck, I have no idea what to do. Here's the things I've tried, I'm just lost. I don't know what's happening next. The old programmer looks at him, he nods, he scratches his beard, and he points to the corner and he sees a duck. And he says, what am I doing with this duck? He says, go over there, calmly, slowly, explain your problem to the duck. Walk through it, step by step, as if you are explaining programming to a duck. The young programmer thinks the guy's crazy, he gives him the dirty look, but he's older than he is. He's wiser. He knows the way of the things. He goes over there and he starts talking to the duck and he explains his problem. He gets about 2/3 of the way through it and he stops short. He looks over at the wise old programmer and he says, that's it. He goes, that's right. He fixed his problem by slowly and carefully explaining it, walking through his processes and seeing what didn't make sense, what he had gone wrong, where he was going. So, great, lovely story. That was awesome. You tell it so well. What's happening here? Threat modeling is a concept that was started, so far as I'm aware, by the security team at Microsoft right around the time of XP Service Pack 1. Now, those dates differ, who claims fame to it differ, things go back and forth. That's not the important part. The important part is the process and what's it mean. It can be any of these things, but it's not. It's super simple. It's a conversation. It's a conversation about a process. Where I've seen it the most is in software. You're taking input, you're doing something, you're storing it or interacting with it further. What's happening there, and where does security fit into that? What happens with things that matter in terms of security? It's all about the process of getting outside of your own head, having that conversation with other people to understand what's happening. So, I've been talking about what I do with software. This is generally the software development lifecycle. You take requirements, you put a design together, you spend a lot of time implementing that, you verify it, you test it, you make sure it hits those things, and then you release it out into the wild. When you build security into that process, it's not just another bullet point on this list. It has to come in at every stage of that. And the software development process isn't much different than the things I've seen for infrastructure or anything like that, where you have these steps. You have to look at what the goals are, you have to look at how you can meet those goals and the budget and put them together. But when you add this to turn it into a security development lifecycle, as we call it, you add these two things up front. You have training, where you learn about the problems that can be presented. You learn about the solutions that can prevent those problems. And then you have the response, where you take responsibility for what you've put out there. At my company, that's a matter of keeping track of our vulnerabilities. We know we have problems in our software. It is not 100% effective or secure. We have to track those, and we communicate, particularly security vulnerabilities, honestly with our customers. We keep a list. Monthly, we publish a bulletin that says, here are the things we've addressed in all these updates. Here's why it's important for you to update. We're keeping that honest conversation alive. And to do that, we have to inject security at every point, so we're finding those vulnerabilities before we release, after we release, when they're reported by other people. There are so many people who have our software that our software is included in scopes that we're not paying for a pen test. We get pen test reports every month from customers who've included our stuff. And sadly, we learn about vulnerabilities that way. And now we look awkward in front of the customer going, I don't know why that happens. I don't know when we're going to get it fixed. But we have that support structure to have that conversation. And where we see the most value injecting into all those stages is threat modeling. It's a conversation. You get some people in the room, you walk through a process, you make some diagrams, you look for gaps. What you're doing is defining things of value. What matters in this process? What matters in this implementation? What matters in what are we doing here in this particular area? Then you look at the potential. Are you taking user data? Are you storing user data? What are you doing to process that data? Is it data at all? Maybe you're doing something else. Then you look at the threats. What possibly can happen here? That's a hard thing to do sometimes. Sometimes it's really hard to get people who haven't ever looked at the threat side of it to understand there even are threats. But then you have to build up that vocabulary to apply them. And then finally, it's the countermeasures. What are you doing to prevent those threats from becoming problems, risks, vulnerabilities in the software? What are you trying to look ahead and stop bad things from happening with? So, how do we take these pieces of a thing? You have raw materials, you have ideas, and turn them into a finished, stable process, a secure thing, something you trust and understand, without it turning into this or this. Everybody at work told me not to use that one, but I'm like, that's official marketing. I didn't put that on the internet. So it all starts with a drawing. Everybody's seen this meme, right? Draw some circles, draw the rest of the owl. Well, when you're doing threat modeling, and we open up, when we're talking to these groups of people, we're saying, first you're going to have to draw a diagram. Half the room starts making eyes. They roll our eyes. They go, I don't know how to draw. I can't draw. I'm like, guys, we didn't hire you for drawing. This is a software organization. We hired you for your ability to think and analyze things critically. So you don't have to get too wrapped up in what are you drawing, just the basics. At the top level, you start with entities and processes. Just different symbols to denote different things are happening. Entities transmit data to and from processes that interact with that data and may or may not send it to a data store. Data stores represent data at rest. Entities are something usually outside of your control, and processes are the things that you can control, you can modify, you're designing or you're altering to make something more secure. Next, you draw paths. Not really like this, more like just a couple of arrows curving to and from a piece of your diagram. So you have an entity that sends data in this direction, and it comes back through this direction. So you have your data flows going to and from entities. The next thing you need to do is chart specifics. What is the format of things that are going back and forth? Is it HTTP traffic? Is it TCP traffic? What does it contain? Does it contain form posts, SQL data, authentication tokens, retrieval, anything like that? You're looking for the specifics of what is moving between 2 points on your diagram, because you're going to use those specifics later when you come up with threats, when you come up with mitigations, ideas of what's happening. So how does that look? You draw an entity that sends data somewhere down the line to a process by following data flows and eventually ends up in a data store. This is all the more complicated your diagram really has to get. There's one more small step, but this is what you're looking for. And I've seen this define infrastructure. I've seen it define high-level code, low-level code. Because it's a thing moving between another thing, it's super simple, and it's the context that matters, the specifics that you have in that conversation. And then the final part of the diagram is a trust boundary. You draw a line around the things that you know matter. And that, in turn, makes an outside. The entity here is stuff you don't trust. The number one way we communicate this with our software developers is, well, we receive things from a client. And they go, yeah, we trust the client. And I said, no, we wrote the client. We do not trust the client. It exists outside of our control, either outside of the network, when it's an internet-facing thing, or still on a user workstation. Because it transmits simple things across the wire like HTTP, anything can do that. And then we break into demos to explain that, because a lot of them don't understand or haven't thought enough to know you can just drop burp, fiddler, something like that on the line, watch what's going back and forth, and modify it in real time. And then inside the trust boundary, though, those are the things, somewhere there's going to be a system of record or the trust anchor. Our software, that's the database. If we can't trust the database, we can't trust anything, and all of our mitigations don't matter. Now, depending on what you're modeling, this might be a different thing. Maybe it's that process. Maybe you have to trust that, and after that, the compromises are some other level in the diagram that you're not dealing with at that particular time. But that's the trust anchor, where your protections, where your mitigations, where your interactions, that's where it all matters. You want to make sure that what's going into that point or what's coming out of that point is the thing that you trust. So everything there treats the data on its way in and out. So every system is built on assumptions. Networks, interactions, systems, software, somewhere in relationship to this diagram. We usually do this on a whiteboard, so we'll have our data flow somewhere in the middle, and then off to one side we'll have a list that says assumptions. We are assuming an authenticated session. We are assuming the user has authorization to these three things that matter to this process. There's something you're assuming that isn't captured in that diagram that you're going to need later when you're verifying everything. Are you only having encrypted communications? That matters, because then man in the middle is a different problem. Are you only using authenticated users? Great. That's wonderful for that conversation, but later you're going to have to go back and verify that. This list is the first thing that's going to become an artifact afterwards that you're going to have to do some work with. Someone or some ones are going to have to take that list and verify those assumptions in relationship to that process. So just to review, you've got endpoints, you've got paths, they talk to one another back and forth, they send certain specific pieces of data for the process you're involved in, you draw a boundary, and you write down assumptions. This is all the harder the actual modeling part is. All the difficult parts after this come from the discussion. What does that process do? What data does it take in? What does it do to it on the way in or out? And what happens, and what are the security implications of that? So, is that it? Absolutely not. That's just the basics. You're drawing a diagram, you're following the path of what's happening through a system, and you're writing down your assumptions. From here comes what I consider the fun part, because I go to places like this to learn from people who don't do blue team, who don't do application stuff, who do the attack, who learn the pen testing things. Now you have to find your threats. You have to imagine what matters to the process you're doing. Are you modeling a network process? Are you worried about network threats? Are you building a new data center and you're trying to threat model that? What matters? Are you worried about nature? Are floods a concern? What can you do there? You have to get specific with your threats and your threat actors of what's going to happen. With our software, we can be concerned about all that stuff, but the person we're most concerned about is some bored user who's trying to either do his job quicker to meet a quota or is bored enough just to test the limits of the system. The specifics of that matter to us because that's the most dangerous thing. If people breach our customers, that's fine, but our reputation is on the line. If someone circumvents the security controls, we sold them in our software. So, again, it's important to be specific about your threat actors. Are you worried about someone who doesn't know how to use the system? Are you worried about someone maliciously targeting whatever's out there, doing things that they've learned either from exploit kits, from watching con talks? Are you worried about fires? Are you worried about acts of God interrupting your services? So once you've determined that threat actor, so in our case it's the bored user, what are you worried about what are you worried that they can do to your system? Are you worried about them dumping your database, finding all your customer data, finding all your sensitive data? Are you worried about the ignorant user? Are you worried about poor passwords? A 3-character password? Who does that? It's a problem. There are mitigations. These things exist in the real world. Are you worried about anonymous or network attacks? Someone kicking you off the internet? If you can list these specific things, it's very easy to come up with specific solutions to them. If you're just worried about having more security, that can be anything. It's super easy to get generic with this stuff and just hand wave it. The point of the threat modeling process is to get in there deeper, to get those specifics out, to write them down so that you have that record afterwards to go, what are we doing in this system? How are we doing that? Where are we doing that? So, writing this, I'm like, that's great. What have we done to prompt people with it? So I came up with questions like this. What has made you mad? People support things all the time. If you're doing this for a system that exists, look at your backlog. What caused you to have these reactions? What are you concerned about? We have a thing we call attack surface reduction. It's super hard to explain to developers, or it was. And then I did the math, and I'm like, okay, every process has compromises, right? They all go, yeah, super. When the CTO comes in and says, we have to ship this thing next month, what do you cut out? They're like, well, nobody wants to tell you. I'm like, this is what that list is for. We know there are shortcuts that have taken security less seriously. Let's put it that way. Not skipped security, not passed over that, but they've taken that as less of a priority than the features and getting them in customers' hands. We want to list those things. We want to keep track of that so that when people have those projects and they say, well, what do you really want to do? We can go, oh, we got this list. How much time do you got? We have 400 things here that we know we can fix that are either low-hanging or super corner case, something like that, that maybe nobody will ever find. But we want to do it because we want to be the best thing we can sell. So if we don't have that list, we can't have that presentation. Going back, specific threats result in specific mitigations. What can you do to stop it? What can you do to slow it down? Liam was talking about the time to exploit in things. No one's system is perfect. No one's system will be perfect. But if you have those specific threats from specific threat actors you're worried about, now you can backtrack to what would stop them, what would slow them down, what would change the interaction. Is it just implementing change control in a system so you know what happened? Sometimes that's a big deal. Is it stricter? Is it different authorization? Strict output encoding, that's a big one at my job. Redundant backups, redundant networks. It can be something very specific because you've outlined that specific threat. If this isn't a design phase exercise, but you're trying to analyze something that already exists, sometimes you have to learn to see things differently. Again, Liam had incredible examples with Bro and IDS and things like that of getting in there and analyzing stuff. Sometimes you don't know what the problem might be, but you can look at where you think it would be and then back that out. Are you worried about specific problems like data exfiltration? Okay, what are the common ways people do that? Things like that. You can get in there and gain that change of perspective. Find that new thing to look at. And here again are questions to get those ideas flowing. What can you change? What can you design out of the system? We did this with a new team not too long ago, and they had a perspective feature up. And they're like, well, and then we do the authentication, but we send it off to this third-party thing, and then they come back, and then we don't take that in, but we send it through this thing. One of the QA testers is, why do we have so many hops for authentication? Don't we do that in the app? And they're like, I mean, yeah. It's just a question. But now they can probably redesign that out of the application because they took that time up front. The devs were just going to do it because that's the way they had always done it. They weren't wrong. They just weren't considering everything at the right time. Having those other people in the room gains and broadens that perspective. What can you do to make yourself less of a target? Maybe you can't make yourself less of a target, but you can slow down anyone who gets there. All those things are different things that you can do to mitigate those problems. So, I've talked about a lot of broad concepts, but how do you get better at this? A couple of years ago, I saw Jason give a talk at DerbyCon about his voyage from being a sysadmin and doing mostly just maintenance tasks to getting a job as a pen tester. Somebody took a chance on him because he had passion and he jumped into pen testing. Okay, great. How do you learn to do that overnight? It's really hard. It's really intense. But here in security, it's fairly easy. You guys are all here on a Saturday. I'm getting paid for this, kind of, but not really. I was coming to these things long before anybody was willing to pay me to do it, long before I was willing to speak or had something to speak about. But everyone here has something different. Everybody knows a little bit more than I do about something, and maybe I know a little bit more about you do than something else, but being here, we can share that. The other great place for this is Twitter. I follow researchers, pen testers, teachers, bloggers, writers, all these people. This is just a quick sample of the people that I'm bookmarking things from. Not even what they say, just what they're retweeting. And if you don't follow InfoSec Taylor Swift, you're missing out on a lot of fun. He, she, whatever, incredibly good user-based security, like this is how I make things work in my environment, and a little bit of fun. But anyhow, everyone's sharing. Everybody's welcoming. When I was doing graphic design stuff, it was like pulling teeth sometimes to learn certain things from certain people when I asked specific questions. Here, you just turn to the guy next to you and say, hey, what are you working on? Oh, I'm doing OSCP. Oh, I'm doing this AppSec stuff. Like, it's wonderful. This environment is incredible, and it's nice to see so many people taking advantage of it. So that's building your intuition. But you need actionable advice. You need something you can take home. I've done a lot of threat models with a lot of people who are at various stages of willing and unwilling. Everyone thinks it sounds super easy. Oh, great. Yeah, super. We can just draw some stuff on the board, write some things down, and then we ignore it and go back to work, and you guys are happy. There's a lot of things that get in the way of succeeding with this. It's easy to hand wave that last step or make a simple mistake and throw off the whole process. However, with that redesign example I gave you, it's also super easy to get immense value out of that. If those QA people hadn't asked why we make so many hops until after they had implemented it, that's months of time down the drain. But having that meeting up front, now they can spend a day or two redesigning it to make it simpler, easier to protect, easier to install, and easier to understand. So yeah, one very, very simple misstep and it all goes for naught. Wait for it. When I dry ran this presentation in front of my team, they threw things at me at the end. Oops. Is this not the best metaphor for security in general, though? How many stories do you read out there of people like, oh man, we got it all right. Yeah, well, what if I say send me cat and they send back most of memory? Oops. So here's some advice I have looking forward. Scope. Especially with a mature software product like I learned how to do threat modeling with, scope is incredibly hard to deal with. Everybody wants to tell you everything about their baby corner of the project and how it works. You have to limit it to a very, very specific thing to get your feet wet with this process, to get that actionable intelligence back out of it, to get the practice doing these things. You have to go, not the user logs in, retrieves, gets this, blah, blah, blah. No, you have to do retrieval. They submit this string, that goes to the processor, that returns this data. You assume there's authentication, you assume there's TLS, you assume whatever. You write those assumptions down in detail. Then you look at what goes forward. What is the user sending at that point? Are they just sending an ID? Or are they sending an ID, a session, their mother's maiden name, the details of their computer because somebody got excited with JavaScript, so they're just pulling everything and throwing it into the post request? Why are you sending that? You can look at the scope, but you have to break these things out super tiny and then validate them. Practice. Another thing that's hard to do is to get people to commit to frequent action sometimes. We found it best to do 45 minutes, half hour, hour meetings once a week or once an interval with all the people you need. Build up the practice of having the meeting, starting the discussion, picking the feature, even if you don't get anything the first few times, but you keep having those meetings. Even if you all sit there and look at each other and going, I don't really know what could be a problem. In our environment, we volunteer for that. We're the application security people. So we go and we say, do you want us to be in your threat model? And they say, I don't know. And we say, cool, send us the invite. If you don't know, we'll be there. If you know, we'll be there. We want to be that other idea. We want to give them that hacker intuition looking forward. What are the bad things that can happen? What are the silly things that you're doing? What are the details that you're not getting at because you're too deep into the process? It's your baby. Nobody wants to look bad when they're in a group of other people analyzing the thing they wrote or the thing they designed. Dovetailing into that, getting the wrong people in the meeting, not having everyone there. In our environment, we want QA and dev in every meeting for every process of every project. If we're not going to get both sides of that table in there for that discussion, it's not worth having the meeting. Because either QA will make all the wrong assumptions about how dev did things, and then they don't follow up, or dev will make all the wrong assumptions about what should be there or shouldn't be there. It's worth skipping the meeting if you can't get the right people. But you got to look at who are the right people to be there. Can you get people who are going to or have used the product in there? As a software company, dev and QA don't use the product the same way our support people do, the same way other people do it inside the company. Sometimes it's valuable to get that advice. If you're designing it, you want to try and get all the people who are going to be affected by it, supporting it, building it, testing it, using it, if you can. The most important slide, and the most important part of all of this that I keep underscoring over and over is you're drawing a diagram, you're writing things down, that's great, you're getting the details, awesome. You had a great meeting, everybody's super kumbaya because you're all coming together and you're finally having this thing and you're staying on topic for 60 minutes of a meeting. Things are going great. As you walk out of that room, you have to have those action items like they tell you in every successful meeting book. Who's going to go off and verify things? Whose responsibility is it to check stuff, to take these things, to go and prove that that stuff exists? Sometimes if it's a design phase, this has to be revisited over and over. As the devs take something or as someone takes it off and implements it, you have to revisit that threat model. Are we protecting the things we said? Are we sending the things we promised we would or didn't? And then you revisit it for testing. Did the devs do what they said they were going to do? Did the implementers do what they said they were going to do? You have to look at that process and prove everything. My boss told me one of the reasons he hired me when I applied for this job is he said, well, what do you do when something you did doesn't work? And I say, I didn't prove it. Part of implementing a system is proving it to yourself and others that it delivers that thing you said. Threat modeling is no different. So I talk fast, and I'm running towards the end of my presentation, but to sum up, it's super simple. It's just a conversation. It's just validating those things. It's hard because it's a lot of work once you get good at it. You come up with a long list of assumptions. The practice part, though, if you're doing this over and over for the same things in the same environments or things like that, you have that knowledge where you have validated that assumption. So you just skip that step the next time. You move on to something new. Okay, we did retrieval. What about storage? Okay, we did storage. What about add a new user? Things like that. You have enough assumptions out of the way. You build that knowledge, that intimate interaction with the product, that you know what's happening. And you get to act like a hacker. You have to learn what people are going to do to break your system. And that's really where I'm at. But looking around, having been to a few of these conferences, I wanted to leave you with another really important message on top of my threat modeling talk. And that's the community of this. If you disagree with anything I've said, awesome. I'd love to hear about it. If you agreed with me, if you've seen what I've done work, if you've seen it not work, anything like that, great. My contact info will be up. You can get it anywhere. I'm on Twitter all the time. I have a blog. I'd love to hear it. But BSides is a community thing. I've met these guys who organized the first one quite a few years back now. What they want is they want more of you up here. 4 years ago, I was in the lobby of a hotel at a hacker conference, surrounded by guys in black t-shirts and tattoos, learning about penetration testing, which I didn't know was a thing before. It looks hard to get up here and do this, but I promise you it's not. It wasn't all that long ago that I was learning this for the first time. Now I've moved on. I've gotten a job doing it. I've become responsible for it. You guys all have something great to tell us all, and the organizers would love to hear about it. When they go to do this next year, I urge you to create a CFP and get involved. And that's the end. If you want a feedback, that's where you can find me. If you want to tell me I'm wrong for something, awesome, I want to hear it. I want to hear all the details. Because this is just how I've seen it. That doesn't mean it's the best way to do it. If you've seen a good way to do it that I'm not talking about, I want to hear that too. But I'd appreciate it if you do it somewhere out in public so other people can watch. On Twitter, if you send me stuff, I'll probably post it to my blog so that that conversation is out there. Because that's where I learned. I learned watching people leading in this field talking on Twitter about the fun stuff they did at work, the stuff they pissed them off at work, the stuff they're learning. And that's it. Thank you all for your attention, and we're a little early for lunch. Oh, yep, you're going to want that.